Division is an operation that we use all the time. It's decision making. It's one of our four major operations that we use in math. And behind me, we have our school cafeteria, and this is an example of where division was used, and also where we are going to use this logical thinking about what we do with the remainder. The remainder can be used in multiple different ways. Sometimes you just drop it and ignore it. Other times you use it as a fraction, or you write it as a decimal to more accurately represent what's going on. And sometimes you round your answer completely up. And these are decisions that you have to make based on the circumstances. There's not a system or a trick to follow. So this cafeteria and some math and division that Mr. Rowe had to do is going to be an example of how we make decisions about the remainder, and is going to be our first example for different ways to represent the remainder. When looking at the cafeteria, Mr. Rowe, our principal, needs to figure out how many tables each classroom will get for their seating arrangement in the cafeteria. And it's a simple division problem for him to solve. So if we take a look at our map, these are all the tables that are in the classroom, and Mr. Rowe just needs to simply decide how many tables each classroom will be assigned while they sit in the cafeteria.
Here we have our division problem in the cafeteria tables. I have 29 students, and 8 students fit at each table. So I need to figure out how many tables I will need for my class. So this is going to be the division problem, 29 divided by 8. I know that 8 times 3 is 24. And I have 5, which means that I'm done the problem. So my answer is 3 5/8. So I have this remainder of 5. Now I think about my 3 choices. If I were to drop the remainder here, then I would be able to have 24 students at my 3 tables, but my 5 would be left out. So that doesn't make sense. Leave it as a fraction. As far as I know, our maintenance manager, Mr. Williams, is not going to be able to cut a table into a 5/8 size piece. So we're not going to be able to have a fraction of a table. My only option is to round up so that I have 4 tables so all my students can fit, and there will just be a couple empty seats at different tables, or 3 empty seats at one table.
Division is an operation where we are splitting up into equal groups. We're sharing. Anytime you're using this strategy, you are doing division. And you're always going to be faced with this decision in real life. What do I do with the remainder? So we could take a simple circumstance of sharing candy. You have a set number of pieces of candy, and you have, let's say, 5 friends. How are you going to equally share the candy amongst them? In this case, we are going to look at some mints. How am I going to share all of these mints among my 5 friends?
To figure out how to share the mints, I can read this problem. Mr. Herman has 33 mints. He plans to share them with 5 of his favorite students. So, to solve, we are doing 33 divided by 5. I know that 5 times 5 is 25. When I subtract, I'm left with 8, which means I can take out one more 5 with a remainder of 3. So our answer is 6 3/5. Now for this problem, we need to again look at our choices. If we leave it as a fraction, a mint really is not a candy or something that I can break up. So I'm not going to leave it as a fraction. If I round up, that would mean each student would get 7 pieces of candy. And if I do 7 times the 5 students, that's 35 pieces of candy. And that is too much. I only have 33 pieces. So we can't round up. So we have to drop the remainder, so each student gets 6 pieces and then there are some left over. It's the only way to make it fair.
Something that I want you to remember is that these decisions you're making, there's not a set system for each problem. So just because we were looking at candy and we decided that we just had to drop off the remainder and leave a couple extra for nobody else to have, because that was the most fair thing, that's not always going to be the case for candy. Sometimes you can make different decisions. Mints are not something that we can really successfully split into half or to split into thirds, split into pieces. Now, if you have a Twix bar and I want to share this amongst friends and I have some remainder left over, this could be something that I easily split in half and I can share between two different people. It would be easier with a knife and you'd be even more successful. So that would be my half, and this half would be for somebody else. Oops. As you can see here, I have my dining room table set up for 6 different people, myself being one of them, and I'm planning on having some friends over tonight. And I decided that we're going to have pizza. So, picture this delicious pizza sitting in the middle of that table, and we have to decide who gets what. Well, pizzas come in 8 slices, so there's 8 slices to share among 6 people. I already know before I look at this division problem that I'm going to have to make a decision to what to do with the leftover slices of pizza. And that's where we're going to continue to use this decision making. What do we do with the remainder?
For this problem, we have 8 slices of pizza being shared amongst 6 people. It's a rather simple division problem. So our answer is 6 and 2/6. So we have to look at our choices. I know we can't round up because there wouldn't be enough pizza slices. We could drop it and just have 2 slices left over, but it seems like a waste. A piece of pizza is something that you can split up. We could split each slice into 3 pieces so that each person could have an extra amount. So each person would get exactly 6 and 2/6 slices, because a piece of pizza is something that we can split up.
Just as a quick wrap up for our lesson today, I want you to remember that there's not a set system. You're using your common sense, you're thinking about the situation, and you're analyzing the word problem after you've done your division. When we go to solve these word problems, you need to focus on what's my division number sentence, and you need to get your answer. And then if there's a remainder, you go back to the problem and you think about the situation, you put yourself in those circumstances and you say, what would I do? How would I solve this problem so that everybody is being treated fairly, but I'm not leaving out anything that I could possibly cut up into pieces or include? Or do I have to round up so that everyone is included as well?